Hi students, good evening. So in the last class we were discussing ionic equilibrium. Some questions we discussed. Okay. So in this class we'll be discussing more questions, and I know that you guys are now aware about the reduced syllabus. Okay. So one important thing I would like to inform you is that since the syllabus is reduced, you know that chemistry is the most affected actually. So there is no inorganic chemistry. Only 4 chapters are present for inorganic chemistry, you know. So we can expect more number of questions from other chapters. So I have little changed our strategy actually. So earlier my strategy was to discuss important very few questions from each chapter, that too very important. Right now I have increased the problems from physical chemistry chapters, especially equilibrium. The reason is very simple. Since this many inorganic chapters are reduced, I am sure that the number of questions from other chapters is going to increase, especially the chapters like equilibrium. Okay, so I want you guys to learn equilibrium chapter like anything. There are many other important chapters like this. We will discuss one by one. Okay, so please enjoy the classes. If you have any option or any doubts or anything, feel free to comment on the comment box. We are here to help you. Okay, yeah. So I have taken up almost all important questions from previous questions, almost other from NCERT, everything I have tried to take it up. So try to enjoy the classes. I will make the explanation that much simple. And if you have any doubt, put it on the comment box. Okay. I think all of you are preparing very well. Okay. So let's start. Yep. So go through the question. Question here is calculate the pOH of a solution at 25 degrees Celsius that contains 1 into 10 power minus 10 molar hydronium ions. Okay, this is the question. So I will explain the concept, then we will go through the answer. Okay, so what is the most important thing when you see a question like this? What and all things we need to note down? One important thing is here we need to calculate pOH, sir. So we need to calculate what? pOH. Okay. The other important thing, this is what we need to calculate. The other important thing is they have mentioned the temperature. So the temperature is very important thing. So it is 25 degrees Celsius, or I can say this is room temperature, that is 298 Kelvin. Very important. Okay. And the next thing is they have given you the hydronium ion concentration, that is H3O plus. And we know that what is the importance of hydronium ion? Can anybody know? Yeah, hydronium ion concentration means it is almost the same as H plus ion concentration. Why? We will discuss that. Okay, so this is given as 1 into 10 power minus 10 molar. Okay, so why it is like that? Because if you consider a hydronium ion, okay, if you consider a hydronium ion, that is H3O plus, we know that each hydronium ion can generate an H plus, a single H plus. Okay, so single H plus and water. So that simply means, what is the meaning of this, sir? So this simply means each, suppose 1 into 10 power minus 10 molar hydronium ions are available. So how will you explain that? What does it mean actually? What does this statement mean? So that means that I can say 1 into, I can write it here, 1 into 10 power minus 10 moles of H3O plus are present in, moles of H3O plus are present in 1 liter solution. So if I am taking a 1 liter solution, it will contain 1 into 10 power minus 10 moles of H3O plus. So tell me, then what will be the, as per stoichiometry, you know that 1 mole of H3O plus can generate 1 mole of H plus. So 1 into 10 power minus 10 moles of H3O plus can generate what? 1 into 10 power minus 10 moles of H3O plus. Okay. So I can easily say that, listen, I can easily say that here concentration of H plus ion, it is a 1-to-1 relation. So that's why we say concentration of H plus ion would be equal to concentration of H3O plus ion. Very, very important. And this is equal to, we already know, 1 into 10 power minus 10 molar. Okay, this is equal to that. Now once you know the H plus ion concentration, we know that we can apply our fundamental concept, that is for OH minus ion concentration. We have the relation H plus ion, okay, into OH minus ion concentration, okay, is equal to what? Tell me, sir. This is very important, and this is equal to 10 power minus 14. Please remember, this equation is valid only at room temperature, that is 298 Kelvin. At some other temperature, this value would be changing. This value would be a different one. Okay, so that's why the importance of temperature is coming here. So let's try to calculate what is OH minus from this one. Then we can put the equation POH is equal to minus of log OH minus ion concentration. Minus of log OH minus ion concentration. So if you do this, you can get POH value. So this is the concept actually. Okay, so let's try to see the problem in detail. Okay, so first thing, as you know, H3O plus ion concentration is given as 1 into 10 power minus 10 molar, and we know that this is equal to H plus ion concentration. Why? We have seen the equation where we found that the number of H3O plus ion would be equal to number of H plus ion generated. From each H3O plus ion, one H plus would be generated. That is the reason why this is becoming equal. Now, since the temperature is mentioned, that is 25 degrees Celsius, I can apply this particular equation. And please remember, this equation is valid only at, when it is valid, sir? This is valid only at 25 degrees Celsius, valid only at 25 degrees Celsius, or we can say at 298 Kelvin. Very, very important. Don't forget this. Okay. Now using this, I have substituted the value for H plus ion, that is 1 into 10 power minus 10. So OH minus ion concentration would be equal to how much? 10 power minus 4. So this get cancelled and this will come in the top, and this will become 10 power minus 4. Now we know that we know OH minus ion concentration. If you want to find out POH, what you need to do? Apply minus log. So I know that POH is equal to minus log OH minus ion concentration. So that is minus log this particular value what we have found out from here. Correct? Now how you can expand this? And this is equal to something like log, listen here, log A raised to M. So this can be expanded as M into log A, like this. So here it is log 10 power minus 4. So this can be written as minus 4 into log 10. Okay, this is the fundamentals of logarithm. And we know that this log is having a base value 10. So whenever both values are same, 10, 10, both values are same, this log 10 is actually 1. Okay, so please remember log 10 is always 1. Why? Because this is also base value is same. And if you take natural log, then E is there, then here also E is there, then this value is also 1. So whenever these powers are equal, this will become 1. So log 10 is 1. So I can write minus 4 into 1. That is already minus is present outside. So the answer will become how much, sir? 4. Understood? So I can easily say my POH value is 4. So let's look at the options. Yeah, if you see the options, you can see 4 is present. So that is my correct answer. Clear? So very simple. I hope you understood. So even though H3O plus ion concentration is given, from that we can calculate H plus ion. From, if you know H plus ion concentration, from that OH minus ion can be calculated if you know the temperature. Because at this particular temperature, the product of these two, is 10 power minus 14. This you should know. Very, very important. Okay, at the 298 Kelvin. I hope this question is clear for you, right? Yep. Can we go to next question? Okay. Now, listen. The question is very simple. All of you please read through the question and try to think about what we need to do. First, we will discuss the concept. Then we will go to the answer. Okay. Yeah. So So let me try to explain. So the number of hydrogen ions, they are asking number of hydrogen ions. It is not concentration, just the number. When the H plus ion concentration means what? The number of moles divided by volume. Okay, it is not that, they are just asking the number of H plus ions present in 10 ml of a solution. So solution volume is mentioned and its pH is given. Okay, so in this question we know pH. We are discussing the idea, so we know this. Okay, if pH is given, what you can do? From this you can easily calculate the H plus ion concentration. This can be calculated. How? Because H plus ion concentration is 10 power minus pH. Okay, you can apply this equation and get H plus ion concentration. So if you know the H plus ion concentration, some value you are getting, then you can expand that. And for example, now suppose you are getting the H plus ion concentration as 10 power minus 13. Okay, 10 power minus 13 molar. So what does this mean? This means that 10 power minus 13 moles H plus is present in how many liter solutions are? 1 liter. Molar means, please, you know, number of moles divided by volume in liters. So this is present in 1 liter solution. Correct? Now how you can further expand this? I can say 10 power minus 13 moles H plus is present in, I can write 1 liter, you can write it as 1000 milliliter solution. Okay, now from this you can easily calculate it. Why? Because they are asking you the number of hydrogen ions in how many ml? 10 ml. So we need to think about in 1000 ml. In 1000 ml, if you are taking this many moles are present. So in 10 ml, what you should get? You need to make it 10 ml. For that we need to divide by 100 on both sides. Divide by 100 on both sides. Okay, so what does it will become, sir? Think. So this will become 10 ml. This will become 10 ml solution, and this will become 10 power minus 13 divided by 100 moles H plus. Now listen, they are asking you the number of ions, so you need to make the number of moles as so we know that right now how many moles are present? 10 power minus 13 by 100 moles. So I can write this as into 1 mole. Correct? 10 power minus 13 by 100 into 1 mole is this particular value, this many moles. Okay, now I can further expand this 1 mole. What is 1 mole actually? 1 mole means how many? So I can write it as 10 power minus 13 divided by 100 into 1 mole is nothing but 6 into 10 power 23. So I can say the number of H plus ions. So this many number of H plus ions are there. So you need to do this calculation. So if you do it roughly, I can say 6 into, here this will become 10 power 10 divided by, this is 10 square. So it will go up, and I can say 6 into 10 power 8 it would become. Correct? So this many number of H plus ions would be there in the medium. Okay, actually we did the question, right? Okay, so we can see whether this option is present or not. Yeah, 6 into 10 power 20, 6.023 into 10 power 8. The same answer we got. So our answer here is option 2 is the correct answer. Okay, I will explain you one more time. So very simple what we have did here. All of you listen. So pH value is mentioned in the question. From the pH we can calculate easily what is the H plus ion concentration, because H plus ion concentration is nothing but 10 power minus pH. You can remember this formula. This is the formula we apply here. Okay, so from this I got H plus ion concentration. Now this means what? From the unit itself, this means 10 power minus 13 moles are present in 1 liter solution. So 10 power minus 13 moles of what? H plus is present in 1 liter solution. Now we need to calculate the number of H plus ions in 10 ml. So in order to convert that into ml, first I convert 1 liter to 1000 ml. We know 1 liter is equal to 1000 ml. Now I am dividing by 100 to make this to 10 ml. So divide by 100. So this will become 10 power minus 15. So divide by 100. So 10 power 2. This will go up and this will become 10 power minus 15. Okay. Now we know that this many number of moles are present. We need the number of H plus ions. Number means we need to convert the moles also into a number. We know that 10 power minus 15 mole means 10 power minus 15 into 1 mole. And we know 1 mole is what? 6 into 10 power 23. 6 into 10 power 23. So you get 6 into 10 power 8 H plus ions. I hope the answer is clear for you. Okay. So students, don't get worried. Actually, many students used to ask me a question, sir, since the syllabus is reduced, sir. Inorganic has completely gone and many simple chapters like chemistry in everyday life, like environmental chemistry, polymers, these many chapters are not present, sir. So what will happen, sir? Whether the question paper will become tough. I cannot say whether it is tough or easy, but I can say one thing. What happens? The core chapters are remaining as such like that. So what we need to say, we need to do more number of questions, as many type of number of questions from each chapter, so that don't even leave even a single topic from a single chapter. Okay, so try to do as many questions, try to clear the concepts. Try to clear the concepts and practice more. And I can say Brainiacs classes there, we are giving very wonderful lectures. You can go to our YouTube channel, go to our playlist. You can see each of the chapters in detail, not like 2 to 3 videos. It is like entire chapter has been discussed. So you can make use of it. And if you have any doubt, you can put it in the comment box, and you feel like, sir, we need a more offline structure, still you can call us. There is a wonderful repeaters batch ongoing with us, and I can clearly say from our last 5 years, we have delivered more than 100 plus doctors to the society, all in the merit section. And all our students are from a humble background with an average score. They came to us like 300, 250, and we made us score more than 650 or 600 above. Okay, so please, you can believe, you can come to us. You can, if you have a passion to become a doctor, surely Brainiacs classes is there to help you. Okay. So let's see. So this question very important. I am even expecting this question in this year NEET exam. Okay, important for NEET. I can write it as NEET. Okay, 2024. Very important question. Why I am telling that? I will explain that why it is like that. So in this particular question, they have asking you which of the following solutions will have a pH value that is close to 1. Now, why this question is very important is because you are given different options. You are given an acid and a base. So you know, between a strong acid and a strong base, there is always a neutralization reaction will occur. So we need to calculate that. We need to check whether the entire solution is acidic or basic. Then based on that, you need to calculate the H plus ion concentration. Then you need to calculate the pH and get the value. So a student should know the entire thing if he need to answer this particular question. That's why this particular question is very important. Okay. So let's try to understand how to do this. First, I will explain you the concept. Then we will go to the detailed explanation. So please remember, whenever you are given, okay, whenever you are given a strong acid, like HCl is a strong acid and NaOH is a strong base, is given, how will you do it? The fundamental thing is, what you need to do is, we know that, listen, we need to calculate the NV value. NV value means N is nothing but normality. Okay, into V means volume. Okay, you need to calculate the NV value of the acid. Okay, then you need to calculate the NV value of the base. Okay, then compare the value. Suppose NV value of the acid, okay, is greater than the NV value of the base. If you are getting it like this, then this means this particular solution is acidic in nature. Okay, suppose you are getting like NV value of the base, okay, is greater than the NV value of the acid. Suppose if you are getting like this, then I can say this particular solution is basic. In that case, the pH value would be greater than 7. If it is acidic, what will happen? The pH value would be less than 7. So from this particular question, we know that they are asking you which of the following solution has pH that is close to 1. They are asking pH close to 1. Okay. Now, if you are trying to do this for all the 4 options, it will take a huge amount of time. So let us apply some logic also before doing it. Okay, what is the logic? They are asking you the pH value should be close to 1. So that means that particular solution is what? Basic. Now I need to identify from this 4 a solution that is basic in nature. Now when I am checking for the first option, I could understand the strength of both are same. If strength are same for both acid and both base, then I can say the volume will determine which is the it is whether it is acid or base, because N into V. N is remaining same means volume will determine. Now here I am saying both are same. Strength is same, okay, and volume is same. So and both are mono base. This is a monobasic acid. That means it can donate only one H plus from one HCl, and this can donate NaOH. So this can donate one OH minus. So it is almost everything are same. So I can say that here the number of H plus ions would be equal to number of OH minus ions in this case. So my prediction, this is would be neutral. This is a neutral solution. So its pH value should be close to 7. Because we know that in the pH scale, suppose this is the pH scale, this is the central thing 7, that is neutral. Okay, and this is something 14 and this is something 1. So between here and here this is acidic, and between here and here it is basic. Okay, here they want pH value to be 1, so surely it is highly acidic. So this won't be the answer. Okay, now let us check the next one. In the next one you see both of them again have the same strength, M by 10, here also M by 10, and here volume strength is large, 55 ml is present. Here base volume is less. So I can say surely this solution would be acidic, and this can have a pH value equal to 1, or anyway I can say its pH value would be less than 7. That is for sure. Okay, now let us check the third one. Third one you have M by 10 and here M by 10. Okay, both strength are remaining the same. But here the volume of base is very high. So I can say this would be basic in nature, and surely it will have a pH value greater than 7. Now let us check the fourth one. In the fourth one, the strength is the same. Here also the strength is the same. But here you can see volume of HCl is far greater compared to volume of NaOH. So I can say this would be highly acidic. This would be highly acidic. So highly acidic means pH value would be near to 1. So with that conclusion, I can say option 4 would be the answer. Why I am not choosing option 2? Because here the volume comparison, it is not that big for acid. So pH would be between near to maybe 5 to 7 it would become. Not near to 1 means highly acidic. So that's why I am going for option 4. So this is how I will reduce my time. I will not do the entire stuff. I can do some logical conclusions like this. Okay. Now we will try to do the actual problem. Okay. So I told you that for a monobasic acid or a monoacidic base, always molarity would be equal to normality. Why? Because we know that normality is equal to n factor into molarity. And for a monobasic acid, this n value would be always equal to 1. This is from our first chapter, basic concept of chemistry. So I can say that for those cases, normality would be equal to molarity. So here I have given you some of the examples for monobasic acid like HCl, HNO3, all monocarboxylic acid, like all carboxylic acid having only one COOH, then HCN. Okay, now example for monoacidic base is NaOH, it can give only one OH, KOH, LiOH. Okay, now I have explained in detail for first option, the molarity is 1 by 5, normality is also 1 by 5, then volume is given as 100. So what we do, NV of the acid, that is 1 by 5 into 100. So this will become 20. Here also molarity, now we are doing for NaOH. So 1 by 5 is the molarity. Normality will be the same because it is a monoacidic base. Molarity is equal to normality. Volume is given as 100 ml. So 1 by 5 into 100 NV of the base. That is also 20. We also predicted the same, right? So here both are equal. NV of the acid is equal to NV of the base. Whenever NV of the acid become equal to NV of the base, then I can say such a solution would be neutral in nature and its pH would be equal to how much? 7. Clear? We also predicted the same, right? Yeah. Now let's check the second option. Second option again, molarity 1 by 10. So normality of the HCl will be 1 by 10. Volume was given as 55 ml. Okay. So NV of the acid is how much? 1 by 10 into 55, that is 5.5. Similarly for base, the molarity is 1 by 10. Normality is 1 by 10 normal. Both are same. Then the volume of NaOH is 45 ml. So NV of the base is 45 divided by 10, that is 4.5. Okay. Now we understood like NV of the acid is greater. We also predicted this. Okay. And this is greater than NV of the base. So I can say that since NV of the acid is greater than NV of the base, I can say here the mixture would be acidic in nature. Okay. Now you want to find out what is its pH value. What you will do, sir? You do a subtraction of these two. Please remember this method, very, very important. Okay, so you do a subtraction, NV of the acid minus NV of the base. Why we are subtracting acid from base? Because this is the higher value. Okay, this is equal to NV. NV means the resultant mixtures normality and the resultant mixtures total volume. So the resultant mixtures N value would be equal to what? The H plus ion concentration. Why? Because the solution is acidic. That's why this normality value is equal to H plus ion concentration. Suppose if it is basic, then this value is, this normality value would be equal to what? It would be the concentration of OH minus. Okay, we will see that. Now what is V? We know that it is the volume of the mixture. So volume of the acid with the volume of the base. So 55 plus 45. So it would become 100. Now I can say 1 by 100. That is, I can say H plus ion concentration is 10 power minus 2. Now you can calculate minus log H plus ion. So 10 power minus 2. So you are getting 2. So our question is they are asking pH should be equal to 1. So this is not the answer. Okay, this is not the answer. Now you take the third option. So third option also you can see normality is 1 by 10 molar. Volume is 10 ml. So multiply this, you will get the value NV of the acid, that is equal to 1. And normality of NaOH is 1 by 10 given in the question, option C. And volume of NaOH is given as very high, you can say 90 ml. So this you are calculating, the value is 9. And I can say NV of the base is here greater than NV of the acid. So I can say this solution would be surely what, sir? If the base is greater, you need to write that. I can clearly say this solution would be basic in nature. This solution would be basic in nature, no doubt. Why? Because NV of the base is greater than NV of the acid. Clear? Now what you do next? In order to if it is basic, then usually this N value would be what? This N value will give you the OH minus ion concentration. Okay. So we again doing the same thing, NV base minus NV acid, that is 9 minus 1, 8. And this V indicates the total volume, volume of the base plus volume of the acid, that you are getting it as 100. So N is equal to 8 by 100. So 8 by 100 means how much, sir? So I can easily say here N value is equal to 8 into how much? 10 power minus 2. 8 into 10 power minus 2 molar. Okay, mole per liter. Okay, that is the strength. Okay, now what you need to do, sir? Once you get this, next thing is calculate the POH, because you got OH minus ion concentration. Very, very important. So POH is nothing but minus of log OH minus ion calculation. So you substitute this, then you know this is of the format log A into B. What is log A into B? Log A plus log B. So I am taking the minus outside and doing it log 8 plus log 10 power minus 2. And we know that log a raised to x, anything coming like this is x into log a. We have seen in the previous question. So this can be expanded as minus 2 log 10. And log 10 is 1. So this would become, or I can multiply inside. So this will become 2 log 10 minus 0.9. So that is 2 minus 0.9, and you are getting the POH value as 1.1. So POH is 1.1 means pH is how much? Don't get confused. Many students will see, sir, we got one value. So option C is the correct answer. No, this is POH. So pH means pH plus POH is equal to 14. This is a fundamental equation we learn in ionic equilibrium. Or you don't even want to learn. You think about the Sorensen scale. It is starting from 0 to 14. Okay, so 1 to 14. So I can say 1 to 14 is a total thing. That is between acid. So pH, and so if you add these two, you should get 14. So pH plus POH would be 14. So pH is equal to 14 minus 1.1, 12.9. I can say it is highly basic in nature. Okay, now let's look at the last option, which is the correct answer. So for that, we taken the N value, that is 1 by 5, volume 75. NV of the acid, we are getting it as 15. NV of the base, we are getting it as 5. From this itself, I can say NV of the acid is greater than NV of the base. So solution is acidic. pH would be less than 7. Correct. Now you do the subtraction. What we did like the previous case, NV is equal to NV acid minus NV base. So 15 minus 5, it would become 10. And volume of the acid 75, volume of the base is 25. So it becomes 100. So 10 here 100. So you are getting 10 power minus 1. And we know that since it is acidic, why? Solution is acidic, this N value would give you what? H plus ion concentration. So I can say pH is equal to minus log H plus ion, and that is 10 power minus 1. So log 10 power minus 1. So minus 1 log 10. So minus of minus 1 is getting you 1 value. So this is how the fundamental method says, and you can do it, but it consumes a lot of amount of time. So first method, what I have told you, is the simplest way to check out one option very easily. Then you can choose the answer. So option 4 is the correct answer, where we are getting a pH value close to 1. Okay, I hope it is clear for you. I have taken all the important, lengthier, tough questions so that you students get a clear idea of how to do that, so that you can practice more questions. Okay. Yep. So all of you, please don't feel bad, sir. Little more time is there, sir. What will do? Nothing. Don't think much, sir. Please start learning. Take your hand and make it work. That's what I used to say to all my students. Make it work, and every day you think about only one question: whether I have worked sufficiently today or not. That is the only question. Don't think about the output. Always work much. And while you are working, always think that whether you are understanding and doing things. That is very, very important. And practice it. Once you practice more, that thing will become automatically fast. You will become very fast in your calculations and everything. Okay. Now let's go to the next question. Students, listen. So we have very beautiful questions waiting for you. So the next question here is, they are given an acid A with a pH value equal to 2, and there is another acid B with a pH value that is equal to 4. Then they are asking a very simple question, which is more acidic? So you don't need to even work out this. We know that pH value between 0 to 7 indicates it is high acidic in nature. Okay. And if the pH value is very less, like between, if pH value 1 and 2 I am comparing, I can say pH value is very less here. So this would be highly acidic. Okay, and this would be lesser compared to that. So I can say as the pH value decreases, solution becomes highly acidic. Okay, so here you have an acid A with the pH 2, acid B with the pH 4. So tell me, sir, which one would be highly acidic? I can say A is more acidic than B, because A have a lesser pH value that is equal to 2 compared to B. Clear? So I have given you maybe a detailed explanation, but that is not required. So you have acid A, pH value is 2. So from that you can calculate H plus ion concentration, that is nothing but 10 power minus pH. So that is 10 power minus 2 molar. So acid B, H plus ion 4 is the pH value. So H plus ion concentration is 10 power minus 4. So we know that in an acidic solution H plus ion would be more. Okay, so I can say here only H plus ion is more. 10 power minus 2 is greater than 10 power minus 4. So I can say acid A is more acidic. Okay, so what you need to remember, this is the most important point to remember. H plus ion concentration increases, acidic strength increases. pH value decreases, acidic strength increases. It is having an inverse relationship. Okay, so H plus ion concentration of A is more than B, that is acid strength of A is greater than acid strength of B, or we can say pH value of B would be greater than pH value of A. Okay, clear? Yeah, that was an easy question compared to the other questions. So let's try to do a very important question. This is very important. I am expecting it for NEET. Okay, so I'm putting here NEET 2024 expected, expected. Now you can ask me, sir, how you are predicting this? Why this come for exam? Very simple, sir. Very simple. I will explain you why I am telling it like that. Now, in most of the questions, we are calculating the pH only. That's why this chapter is tough for many students, because in all the questions we do calculation of pH, but the solution will keep on changing. In the previous question, we taken a strong acid and strong base. For that, we done neutralization reaction, that is NV of acid we calculated and NV of base we calculated, and we calculated the pH. But here I am not following that approach. Why? Because here you have a strong acid and a weak acid is given. Okay. Now a weak acid means, what is the peculiarity? A weak acid, it states that it is a 0.1 molar solution. That means 0.1 moles of CH3COOH, okay, is present in 1 liter solution. But this entire 0.1 mole will not dissociate because it is a weak electrolyte. It is a weak electrolyte, so its alpha value would be less than 1. So I cannot ensure that entire thing will undergo what? Ionization. So that's why this type of question, whenever a weak electrolyte like stuffs are there, we need to think about whether there is a possibility of buffer or not. Okay, here we know that weak acid with conjugate base of the same weak acid can constitute a buffer. But here weak acid is CH3COOH, its conjugate base is CH3CO-. Fortunately, this is not, it is HCl, that is something different. Okay, so I can say, but here one important thing, HCl is a complete solution, so it will undergo ionization like H plus and Cl minus. So what will happen? Some of the CH3COO minus will form react with this one and form CH3COOL. Now you can see CH3COOH. So this is a weak acid with its conjugate stuff. So like that, many possible combinations are there. So this like questions, how we need to do it, I will explain you. Listen. So we know that it is a stronger acid. So 0.01 molar HCl means 0.01 mole of HCl is present in 1 liter solution. So we know that it has alpha value 100%. We need to mention that. Very important. Here for HCl, alpha would be 100%. Why alpha is 100%? Because it is a what? Strong electrolyte. It is a strong electrolyte. For all strong electrolyte, alpha would be 100%. So I can say that this will undergo complete ionization. So there will be only one arrow like this. Okay, sorry. So let's take that. 1 minute. Just a minute. Yeah. Open with, we have good notes. Yeah, good notes opened. Okay, we'll try to see. Yeah, so we were doing this question. So listen here, students. So we have HCl, which is a strong acid. So I can easily say this will undergo complete ionization. Entire HCl will get converted to H plus and Cl minus. So we have taken 0.01 mole in 1 liter. So initially this is at a time t is equal to 0. At a time t is equal to 0. We need to mention that also. Okay, that is at a time t is equal to 0. And this is after some time. Let me say this is after some time. After time t. Okay, so it will become very clear. So initially this is only present, nothing formed. So once it is dissolved in liquid, we know that this is strong electrolyte. So entire thing will ionize and this will become 0 mole, and we know that 1 mole can give rise to 1 mole of H plus and 1 mole of Cl minus. So 0.01 mole can give rise to 0.01 mole of H plus and 0.01 mole of Cl minus. Now we know that H plus generated in the medium is now 0.01 mole because we need to calculate pH, right? Now let's take the weak acid, that is CH3COOH. We know this is a weak electrolyte. Surely its alpha value would be less than 100 and we don't know what it is. That is the most important thing. It is not mentioned in the question. Okay, so alpha would be less than 100%. Okay, and this is not mentioned. If you know the exact alpha value, then only we can calculate how much amount is dissociated from 0.1 mole. So here 0.1 molar solution means 0.1 mole of CH3COOH is present in 1 liter solution. So at time t is equal to 0, we can say 0.1 mole of CH3COOH is present, but nothing of this is formed. Now as the time progresses, usually alpha will dissociate from here. Okay, alpha will dissociate, or we can say C alpha would dissociate. C alpha means what? Alpha is always defined for 1 mole. Now here you have 0.1 mole is present. So usually how much would dissociate? 0.1 alpha should dissociate from here. That is what is X here. So instead of writing it as 0.1 alpha dissociated, I am writing that as X. Okay. So X mole is dissociating. So what will happen? 1 mole can give rise to 1 mole of acetate ion. So X mole can give you X mole. Here also X mole. So here all it is 0.1 alpha. Okay. Now, but since we don't know the alpha, we cannot calculate an exact value. That is the problem. So here what would be remaining here? 0.1 minus X, because X has already reacted and give rise to this. Correct? So this is what is remaining. And here acetate ion X and H plus ion, because we need H plus ion for our calculation. And how many amount of H plus ion is formed? X, that is equal to 0.1 alpha. Okay. Now let's calculate the total H plus ion concentration. Total H plus ion concentration is total number of H plus moles. That is how much? 0.01 plus 0.1 alpha. Since 0.1 alpha, this alpha value is very less for a weak acid. We can say alpha would be very less for a weak acid. We can say this 0.1 alpha, X is equal to 0.1 alpha. This value would be very less. So we are here ignoring this X actually. So we are taking only this particular value. That is the H plus ion that is generated due to what? The strong HCl. That is the most important thing to remember. So here what it would become? 5 into, this would become 5 into 10 power minus 3, and we are ignoring this. Why? Because X is very much less. Okay, we don't know alpha. Okay, so H plus ion concentration is 5 into 10 power minus 3. So we are applying minus log H plus. So you apply that A into B. So log A minus log B. So you are calculating it and you are getting a value that is 2.3. So I can say this is approximately 2.3. Okay, so I will look at the options, and option they are given option 2, that is 2.3. Understood? So whenever there is a combination like a strong acid weak acid combination, always check like this, and if you are given pKa value and all, you can consider the here as a buffer formation and you can do it. Okay, here pKa is not mentioned, so we can do it like what I have explained in the question. Okay, I hope it is clear for you. Okay, next question is also very important. It's already came for the exam. Very important. They have given you equal volumes of three acid solutions having pH 3, 4, 5. They are mixed in a vessel, and they are asking you what will be the H plus ion concentration for this particular mixture. So you know that here first acid, we know the pH. So pH is given as 3. So from this I can calculate H plus ion. That would be 10 power minus 3. And for next one also we know pH is equal to 4. So what you can do, you can calculate the H plus ion concentration, that is 10 power minus 4. And for the third one also they have given the pH value is 5. So H plus ion concentration would be how much? 10 power minus pH, that is 10 power minus 5. So what you need to do, next, if you want to find out the total pH, you need to calculate the total H plus ion concentration, which is nothing but total number of moles. Total number of moles of H plus divided by total volume. Total volume. Because you are mixing equal volumes of three acid solutions. So total volume would be, we need to add. Here if I am taking this as 10 power minus 3 molar for acid A, means 10 power minus 3 moles are present in 1 liter solution. Okay, so let's see the answer. Now we are assuming let 1 liter of all the three acid solutions are mixed together. Why? Because we are defining pH is equal to 3. 10 power minus pH means 10 power minus 3 molar. How 10 power minus 3 molar is elaborated? This means 10 power minus 3 moles of H plus is present in 1 liter solution. Okay, so that's the reason why we are assuming everything to be 1 liter. Now for the acid solution B, they have given the pH is equal to 4. So again H plus ion concentration would be how much? 10 power minus 4 molar. I forgot to keep here molar, but please mention here it is molar. Okay, so this means what actually, sir? This means 10 power minus 4 moles of H plus is present in 1 liter solution. Now acid solution C also you can see pH is given as 5. So H plus ion concentration would be how much? 10 power minus 5 molar. So again the same thing. Now calculate the total H plus ion concentration, which is nothing but total number of moles of H plus ion. So we know the number of moles here is 10 power minus 3 moles present in 1 liter. Here 10 power minus 4 moles present in 1 liter. Here 10 power minus 5 moles present in 1 liter. So we add all the number of moles. Now we know that all these are present in 1 liter solution. We add 1 plus 1 plus 1. So you get 3 liter total volume. Okay. Now we need to calculate this. How we calculate this, sir? Take 10 power minus 3 common. How? Dividing by 10 power 3 entirely. So 10 power minus 3 I am taking. So this would become 1 and this would become what? 10 power minus 4 divided by 10 power minus 3. That is 10 power minus 1. And 10 power minus 5 you divide by 10 power minus 3. This would become 10 power minus 2. So you get something like, you can say 1 plus 10 power minus 1 plus 10 power minus 2. So how will you calculate this? So many students have a doubt in this one. So we do like this, 10 power minus 3 by 3. So this can be written as 1 plus 1 by 10 plus 1 by 100. Correct? So this can be written as 1 plus 0.1 plus 0.001. Now tell me, sir, what does this mean? This is 1 point, okay, this is points. So this is nothing but 1.11. So I can say you will get here what, sir? 1.11 by 3 into 10 power minus 3. So I am multiplying by 10 on both sides. So this will become what? I can write it as 11.1 by 3. This 10 I am taking in the numerator. So this will become 11.1 by 10 power minus 4. So 3 by 11.1 by 3 is 3.7 into 10 power minus 4. This is how I am arriving at this particular answer. So the answer for this question is what, sir? Answer for this question is option 3 is the correct answer. Okay. So I will stop here today. So we have lot of questions coming for you, many questions. So I have taken, you can see here that many questions are here, like 9800 pages with all detailed explanations, everything. Okay, after the entire classes I will upload this this a PDF also here. You can download it and make use of it. Okay, so again I am explaining from our side. So we are part of, I can say, Brainiacs Classes. Okay, Brainiacs Classes. So we have delivered 100 plus doctors for our society in our last 4 years, and this is one of the best NEET coaching center available in Coimbatore. So please subscribe our channel to get more revision videos. Please take a book and pen and paper along with you and start doing along with us. Surely we can crack the NEET together, this particular NEET 2024. Okay, so stay tuned, stay in touch. We will see next Sunday again at 4 p.m. Okay, thank you.